The BITOR function within Excel allows us to perform a bitwise OR operation on two decimal numbers. So let's test this out. I have two numbers here, 136 and 301. So we type =, BITOR, and then we provide both numbers as separate arguments. So number 1, number 2, I press enter, and a new number comes out. Now the new number is the result of a bitwise OR operation. Now what does that exactly mean? Well, in order to better understand that, we must know what it means to go from decimal to binary, and also what it means to perform an OR operation. Now let's start with an OR operation. An OR operation allows us to check if we have two logical tests, at least one of them needs to be true in order for the result of the OR function to be true as well. So let's write true, true, false, false, and then we're writing here true, false, true, false. And so now we have four possible combinations of two statements that are either true or false, right? So I could say I have a dog, and then I love to walk, right? And so that those statements could either be true or false. They are logical tests. Now, in the case of Excel, usually we'll be saying, okay, cell A1 equals 1, cell B2 is bigger than 10, statements like that. Now, if we perform an OR on these ones, we simply provide each statement as one argument, and we press enter, and we look at the result. Now, what you can notice is that the OR operator will always return true if at least one of all of the provided statements are true. So that is the case in these three instances. Only in the last instance, where both logical tests or statements are false, does the OR return a false. Now in this case, we have used true and false, but do know that computers represent true and false with 1 and 0. So I could do exactly the same thing with ones and zeros, where zeros would represent false and true would be represented by 1. So if I now do OR, and I have these logical conditions as 1 and 0, you can see we get exactly the same result. What we could even do is you could also transform the resulting true and false to 1 and 0. So how we would do that is using an if statement, and then we use an OR statement inside of the if statement. And so with the if statement, we have one logical test that returns true or false. And so depending if it returns true or false, we'll be returning something else. Now in this case, the OR statement takes exactly the same arguments as before. So then we have to provide a value that will be put into the cell if the logical test, so what the OR returns, is true. Well, then we want a 1, otherwise we're looking for a 0. So the third argument of the if statement is what is being returned if the returning value of the logical test is false. So I close the parentheses, and now I pull this through. And so what we are now getting, we are inputting ones and zeros, and out comes ones and zeros. And so this is what we call an OR operation. We look at two bits. A bit can be a 0 or a 1. And then depending on their status, we return a 1 or a 0. And with an OR statement, if at least one of the two bits is a 1, then we return a 1, otherwise a 0. These bits, being 1 and 0 or true or false, is something that we also call a Boolean. That's simply a number type or a data type that can represent true or false or 1 or 0. That's what we call a Boolean. Okay, so far so good. Then the next thing we need to look at is the binary number system. Now, if you have a number like 136 that consists out of 3 separate digits, 1, 3, and 6. Now, the value of each digit is determined by its position in the number, right? So this 1 represents 100, whereas this 3 represents a 30, and the 6 represents a 6. Now, why is that happening? Well, it's because the value of the first digit is 1, the second is 10, and the third is 100. And it continues like that, right? So the fourth would be 1,000, the fifth would be 10,000. It would each time be multiplied by 10. To then get the value of that respective digit, we simply multiply the digit with its weight. We do that for all digits and then add them up. So we use a sum function for this, which adds all of these numbers together, and we get 136. Now, this is the decimal number system. There exist many other number systems, and one of the most well-known one is the binary number system. Now, we can convert a number into binary using the DEC to bin, so decimal to binary conversion function. All it does is we have to provide it a number, we close the parentheses and press enter, and there we have the binary representation of this number. Now, what does this mean? Well, let's write it out. So we have a 1 followed with 3 zeros, and then a 1 followed by 3 zeros, just like that. So this represents the number 136 in binary. If you remember, with a decimal number, the first digit has a weight of 1, the second 10, and the third 100. Well, it works in a similar fashion, but how it works in binary, the first is 1, the second is 2, the third is 4, and so we each time multiply by 2. So I can simply take the previous weight and multiply it by 2, just like with the decimal number system, I could multiply with 10 each time. So I pull this through, and so now we have all of the weights of the different digits, right? So a digit in the 8th position of a binary number has a weight of 128, whereas a digit on the 5th position has a weight of 16. Just like we did earlier with the decimal number system, we multiply each digit with its weight. We do this for each digit, and then we add up the result. And as you can see, the result is also 136. So indeed, this number in binary represents 136 in decimal. Okay, so now we need to combine our knowledge of the OR operator and these binary numbers to see how we end up with a 429 when we use a bitwise OR operation on these two numbers. So the first thing we will be doing is we will be converting these two numbers into binary. So we have 136 and 301. So we use DEC to bin function to convert them into binary. And now we list both numbers out. So the first one is 136. So we have a 1 and then 3 zeros and then a 1 followed with the 3 zeros again. So this represents 136. Then we have 301. So that's a 1, 2 zeros, a 1, 0, 2 ones, 0 and 1. So you can see in order to represent the number 301 in binary, we need one additional digit. So therefore I will be shifting down 136, 1 down. And so what we could do is put a 0 here, right? It's simply nothing. It's like if we would write 036, right? This would also represent the number 136 in decimal numbers. Well, it works the same way for binary numbers. If you have a 0 in front, we simply don't count it, right? So if I press enter in Excel, you can see it automatically converts it to 136. The same thing applies to decimal numbers. So now we apply our OR logic, right? So the OR logic is if that is at least one of the two numbers has a 1 or is true, the result is also true. So this would be 1, this would be 1, this would be a 0 because both numbers have a 0 at that position. Here we have a 1, here we have a 0 because both numbers are 0. And so if you have at least one 1 in the two numbers, it's a 1, otherwise it's a 0. Okay, so this is our new result. So let's write this out. So we have two 1s, a 0, a 1, 0, 1, 1, 0, 1. So this is the new resulting binary number. So let's convert this now using the function bin to decimal. And what this does, it takes in a binary number and converts it into a decimal number. So I present this and you can see the result is 429, which is indeed the result that we got with the BITOR function. So with the BITOR function, we supply two numbers to it in decimal form. And then the result is the decimal number after having performed a bitwise OR operation on those numbers. So it's very important that the inputs to the BITOR function are actually decimal numbers and not binary numbers. I have converted them to binary numbers to explain what is going on behind the scenes. If you found this helpful, consider subscribing to the channel for more videos like these. You can also leave a tip using the PayPal link in the description. Thanks for stopping by. Feel free to watch this recommended video.